Hey guys, now we're back for some solving radical inequalities. Now solving radical inequalities, I'm going to do much the same as I did with solving equations, right? I can still divide and square and do all that stuff I did with equations, but what's a little trickier is checking my answer. Because when I get an answer here, it's not just going to be x equals something. So I need to find another way to check my solution. And that's what we're going to do when we get to step 2. My hand, I couldn't write out all the stuff on the note sheet, so I'll read it, we'll look over it together, but I wasn't able to write it all out. Okay, so step 1 is just to solve the inequality, right? So we want to isolate the square root just like with an equation. So let's divide both sides by 3. And I get the square root of x minus 1 is less than or equal to 4. Okay, now let's square both sides. And that gives me x minus 1 is less than or equal to 16. Add 1, and I get x is less than or equal to 17. Okay, guys, I'm hoping you see why I can't check every solution. I'd be sitting here for my entire life trying to check every number less than or equal to 17 because those go all the way to negative infinity. So I can't just start plugging numbers in here, right? That's not going to make any sense. But I need to check for a potential problem that I might encounter for certain values of x. So if you guys remember, I can't have a negative number under a square root. Not without going into I land, right? Which we're not doing, we're just looking at real numbers here. So would you guys agree that that means that the square root of x minus 1, which is what our square root is, has to be positive? Right? So there are some values of x that would have an issue, right guys? What if I put negative 4 in there? Well, if I put negative 4, I'd have the square root of negative 5, which I can't have. So I need to come up with a way to set this up so that I can figure out what values of square root of x minus 1 are positive. Well, positive means, well, not positive, positive or 0. So what positive mean, or 0 would be greater than or equal to 0. So what that means is that I need this potential constraint on my answer, x is less than or equal to 17. That also has to be true. Sorry, not the square root. The actual, right, this x plus 1 has to, or x minus 1 has to be greater than or equal to 0. Right? Otherwise, I'm going to end up with a negative number under there. So, and actually, sorry, it's really the x minus 1 that has to be greater than or equal to 0, because that's what's under the square root. So in addition to the fact that x is less than or equal to 17, it's also true that x has to be greater than or equal to 1. So both these must be true. So how do I combine this into one statement? Well, I need numbers less than or equal to 17, but also those numbers have to be greater than or equal to 1. So I can write it like this. X has to be in between 17 and 1. Because once I get less than 1, then I got a problem, right? If I make this less than 1, well, let's try it. If I make it less than 1, let's say I made it, I don't know, 0, right? Let's say I put a 0 in there. I end up with a negative, right? I can't do that. I can't have a negative under there. So we're called, here what this is called is checking the domain. That's how I check an inequality, which is definitely a little different than just plugging in a single or one or two solutions. Okay guys, let's try one more. And by the way, this domain check is the step that people skip. So you gotta make sure you do both steps. Checking your solution's just as important in an inequality. Okay, let's do this last problem. I threw in a little bit of negative stuff here, just to remind you of something. Okay, guys, think back to Algebra 1. When I divide an inequality by a negative number, right? If I divide by a negative, I have to flip the symbol. I have to flip the symbol when I divide by a negative or multiply. Right, so now what I've got, if I divide by a negative, I end up with the square root of x plus 5. Instead of less than, I now have greater than. Okay, guys, let's square both sides, right? We got our isolated square root. That gets me x plus 5 is greater than 49. Right, and that gets me x is greater than 44. All right. Okay, so my inequality says x has to be greater than 44. We also have to check the domain, right? So what I'm going to do is I'm going to take what's under the square root. In this case, it's x plus 5. And I need to figure out, okay, well, what values make x plus 5 0 or more, right? Because I can't have the square root of x plus 5. I can't have a negative number under there. So both these things have to be true. Okay, so let's think about this for a sec. We're going to try to combine these two things into one inequality. So if I know that x is greater than 44, and I also know that x is greater than or equal to negative 5, well, if x is greater than or equal to negative 5, the x is greater than 44 kind of includes that already, right? Any number greater than 44 is, by definition, has to be greater than negative 5 as well. So I can just combine this into one inequality by saying, okay, that means that x must be greater than 44. So in this case, the domain didn't actually limit my original answer, but I always have to check to make sure that it doesn't, like it did on the first one, right? So I always have to make sure that both of these are considered in my final answer. Okay, guys, have fun with the practice problems. I will see you soon.